Hello and welcome to What the Math. Today we're going to terraform the entire solar system. When I say entire solar system, I of course mean the 8 planets. I don't think I can probably terraform any of these objects here, which are dwarf planets, but I'll try doing one of them. So we're gonna start with Mercury and basically go outwards, and this is the technique I used, or basically I'm going to use techniques that I've used in the previous videos. So with terrestrial planets I'm going to use one thing, with the gas giants I'm going to use slightly different thing. Now I'm not gonna go into detail, but basically you'll see the beginning and the result. So let's start with Mercury. I'm gonna zoom in on it. So here we're going to lower the albedo so that the planet doesn't receive as much sunlight, and add some atmosphere and possibly even mass. I'm also going to use a dispenser to give it a little bit of water and a little bit of carbon dioxide and possibly a little bit of organics as well. This will obviously create the atmosphere once I add it here, and this is atmospheric mass, which will be a little bit higher than this. And here we go, we have average temperature of 41 degrees, it's still a little bit too hot, albedo of 94%, greenhouse effect of 107 Kelvin, relatively low pressure, but it's sort of like living up in the mountains somewhere in the Himalayas, except it's really hot. And we have carbon dioxide, we have organics, we have some water, and unfortunately it's not green yet, but from what I understand it takes time for it to get green. So let's go to the next planet, which will be Venus. And here it is, here's Venus. I'm going to zoom in on it as well. Now here the problem is that we have too much atmosphere, we have too much greenhouse effect, so we're going to remove this using our super technology that will bind the atmosphere with the ground on the bottom, and will create more material, more rocky stuff, but less gas. So I'm just going to go in here and decrease its atmosphere. And here we go, you can see it transforming already. Oh, too much water. I'm going to increase water. And it's almost livable, almost habitable. There's still a little bit too much atmosphere, but I'm going to decrease it in 1 second. And here we go, temperature of about 33 degrees, albedo of 71%, greenhouse effect of 89 Kelvin or 89 degrees. And almost Earth-like pressure. So this is actually very livable. You can easily have a good vacation here. It's still a little bit too hot. I may actually increase my albedo just a little bit. And it has water, it has organics, it has carbon dioxide. So everything to support life. So hopefully it will turn green at some point. And temperature is still a little bit too hot, but it's actually going to decrease a little bit. Next planet is Mars. And welcome to the red planet. So here the problem is the opposite. We have not enough atmosphere and not enough greenhouse effect. So what we're going to do is we're going to shower this planet with atmosphere and make atmosphere just a little bit more pressurized than on Earth. And for this we're going to use our dispenser to give it some more carbon dioxide and some more water. And look at that, it turned into a nice planet. That's because it's too cold right now, so we have to increase the temperature. And here we go, the ice planet has melted and is becoming a water planet. So I think I actually added too much water. I'm going to decrease it a little bit just to give us some land to live on. And everything else is perfect. We have slightly higher atmosphere, but actually that's not a problem for us as a species, because humans can easily live at high pressures. We can't live at low pressures, but we can easily live at high pressures. The temperature is getting warmer, so I'm not sure how high it will go, but we'll see in a second. But give us some more land. I'm going to give us some more land right here. There we go. We have a big continent and a big ocean in the north. And the temperature I think it will balance out around 20 degrees. So I'm just going to accelerate the time and see how hot it gets. And here we go. This is an Earth-like Mars. We have 27 degrees Celsius temperature. We have Earth-like atmosphere, and everything else is, well, except for greenhouse effect, which is a little bit too high. Everything else is Earth-like. But we need the higher greenhouse effect because it's farther away from the sun. And we have some water, we have some organics, we have some carbon dioxide. Alright, so we've just terraformed all our terrestrial planets. Everything looks like Earth now. Let's go with the gas giants. So the first one we're going to take a look at is right here. And it's of course Jupiter. So let's zoom in on Jupiter. Now this is probably going to be a little bit more challenging, but basically what we want to do here is we want to get rid of all of this atmosphere, reach the core, reach the terrestrial planet that it has underneath all this gas, and then what we want to do is we want to basically turn all of this gas and all of this extra mass into an orbiting series of rings around the planet, which is what I did in the previous video, which is basically how we can still maintain all the mass and all of the gravity field around Jupiter, which is what it needs, but still make it habitable for humans. Because if we try to live on this planet right now, you can see it has mass of 318 Earths, which is, it's going to squish us. It's going to be gravity of like at least 10 times higher than on Earth. We need to decrease this somehow, and the way I decreased this in the previous video is by making a series of rings around the planet, a lot of rings, which will essentially turn this into an Earth-like planet, but with a Earth-like gravity as well. The gravity will be distributed across the entire sphere, not sphere, what is that called? The entire area of this circle, which I'll show you in a second. I'm going to try to make it as authentic as possible, but before we go there, we need to remove all of this extra gas. So all this hydrogen has to be bound with the terrestrial stuff on the bottom, making it silicate. So this will turn into a rocky planet. And as I turn it into a rocky planet, it actually acquires a lot of density and its size starts decreasing. So it's actually going to shrink a little bit and turn into a kind of a small-ish planet. Still bigger than Earth, but not as big as it was before. Now, while we're waiting for this to happen, I'm going to start introducing various things, such as water, organics, and carbon dioxide. And this is when we're going to start decreasing its mass. So I'm going to change this to, let's just say, 1 Earth for now. So it will actually shrink even more. And all this extra mass will be added as a consecutive series of rings around the planet. And this is what this series of rings would look like. It wouldn't move in such a manner probably. This is happening because I changed the mass a little bit, but it would be even more concentrated. This would be like everywhere. I don't think my computer can handle so many particles at the same time, so I'm going to keep it here. But essentially it will look something like this. It will be flat, and there will be like an entire mass of Jupiter orbiting around it, with the exception of possibly 1 or 2 Earth's masses that is still present on the planet, just to maintain that needed atmospheric pressure and gravity. And basically now we just have to add atmosphere and all the other stuff we did on the other terrestrial planets, and we will have a perfectly habitable terrestrial Jupiter. Now while I'm waiting for it to warm up, I'm going to go ahead and do the same thing for the other 3 gas giants, because they will actually have a very similar technique. They'll need to have these rings, and they'll need to have all their mass distributed across the field right here, just like that. So that the reason we're doing this is because they do have a lot of satellites, a lot of moons orbiting around them. And so if we actually decrease their mass, all those satellites are going to fly away and probably smack into our planet. So we need to maintain the gravity field around them, yet we need to have a gravity field on top of the planet where we can survive. So it has to be very low for human beings to survive. So let's just go ahead and do the same with Saturn. Now here it doesn't actually have any rings because I'm using the solar system simulation that doesn't give Saturn any rings. So I'm going to give it manual rings myself. I'm going to give it extra rings, even more than it had before. But unlike Jupiter, Saturn will actually need even more greenhouse effect. So I'm going to have to increase its atmosphere even further. Meaning that as we go away from the Sun, the atmospheric pressure of gas giants will actually increase. So in other words, on Jupiter we'll have a relatively low atmospheric pressure. It will only be about 7 atmospheres. So that's something that humans will actually not notice, but the only difference is that it will just feel a little bit more stuffy. And on Saturn it will have to be even more. It will have to be a much higher because we want to maintain a high greenhouse effect, and we want to maintain this terrestrial temperature. And to do this we'll need more atmosphere to increase the greenhouse effect. But then that also means that on the last gas giant, we'll have the highest atmospheric pressure. And basically this is what it's going to look like as well. So it's going to be very, very similar to Jupiter. I'm just going to wait for it to warm up. It will probably have less rings because it doesn't have as much mass as Jupiter. Let's go to the next gas giant, which is right here. Oh, I think I made a small mistake. As I accelerated time here, I forgot that the game is not actually able to calculate orbiting paths for every single object, especially the tiny ones. So all of my rings that I had around Saturn and Jupiter just flew away because they weren't actually being the parameters for their orbit wasn't being calculated, so now they're all over the place. I'm gonna have to redo the rings afterwards. So let's just focus on basically warming up all of the gas giants first. And the next on the list is Uranus. So let's go to the blue planet and make it beautiful and blue, but habitable as well. It's actually spinning really fast. I'm going to decrease the speed. And there we go. That's a little bit better. So same thing, but here the mass is much lower, so the rings will actually not be as profound as on Jupiter, because it only has 14.5 times the mass of Earth. But it will still need to have those rings, because I don't think we can actually survive on a planet that has such a high gravity. I mean, we could survive, but it just wouldn't be very comfortable, so it wouldn't be a terrestrial planet. So let's go ahead and decrease that atmosphere. And there we have it, Uranus, the blue planet. There's a little bit of land right there, and there's a little bit of land right here. So basically this is a prime real estate for people that like water. Now the thing about Uranus is that it has a huge atmospheric difference. Now because it's so far away from Earth, it needs as much greenhouse effect as I could get. So it actually has 227 degrees of greenhouse effect. And its surface pressure is 241 times the surface pressure on Earth. Now, is that a problem? Well, not really, because, like I said before, humans have no problem surviving in high pressures. This is why we can scuba dive. We can actually go down to any pressure, because we're basically made out of water. And water does not, if you try to pressurize water, it doesn't actually condense. So that's why we can actually easily survive on even under such high pressures. The only problem is obviously will be transferring to Earth after this, but this is where you can, you can fly inside a pressurized chamber that will, that will actually help you adjust to new pressure changes. Now, the temperature here is pretty nice. I believe it is very nice, 16 degrees Celsius, and atmospheric mass is relatively high, but this is why the pressure is high. Albedo is quite low, so everything else is perfect. The gravity is also Earth-like. It's only 1.13 mass of Earth. So this is a very perfect water world to live on. And the last planet is, of course, Neptune. So let's go to Neptune and do the same to it as well. Now, Neptune is the bluest planet that we have. So I'm going to turn this also into a water-like environment, but hopefully with slightly different landscape. So let's remove its atmosphere and make it terrestrial. And here we go, transforming Neptune. It's actually looking pretty good already. Look at that, it's so blue. I didn't expect this to have this kind of effect, but as it's decreasing its size due to its sudden turn into a terrestrial planet, I'm going to actually go ahead and add some atmosphere to it and make it warmer. And actually, right now it turned into the blue ice planet. This is beautiful. I didn't actually expect to have such an effect. This is awesome. Maybe I should just leave it like that. No, I'm going to make it an Earth-like planet. And there we have it, 14 degrees Celsius. A very blue planet. This is, I believe this is actually land, and this is water. So it looks blue even on land, which is pretty awesome. So, but that's a very terrestrial-like planet. The atmosphere is much higher than on the previous planet, than on Uranus, but that's still not a problem. It's 670 atmospheres right now, but we can handle that. We can survive that. Alright, so I think it's finished, so let's take a look at what we've created, starting with the innermost planet, Mercury. I just have to find it, it's so tiny. Where is it? It's somewhere here. I think this is it. No, that's Sun. There we go, Mercury. So let's zoom in on it. Perfectly habitable planet, a little bit too close to the Sun, but it has an average temperature of 43 degrees, so it's a little bit too hot. I may actually even, I think I may have to decrease my atmosphere just a little bit to make it a little bit more habitable. And it will have just slightly less atmosphere than on Earth, which is still okay. It's not too bad, but it will have actually better temperature that way. Then we have Venus. Where's Venus? Let's zoom in on Venus. Venus has temperature of 36 degrees and beautiful landscapes. It's orange and blue, and hopefully it will turn green at some point. And greenhouse effect has been decreased, and everything else is just perfect. Surface pressure is a little bit low, but it's still habitable though. Next, we have obviously Earth, and after Earth, we have Mars. Mars is almost completely Earth-like. Very good temperature of 15 degrees, excellent landscapes. We have beautiful landscapes here. There's a lot of land in the south and a lot of ocean in the north. Everything else is very Earth-like. Temperature, atmospheric pressure, and surface pressure right now is 1.01 of Earth pressure, which is basically indistinguishable. You will not be able to tell a difference. And then we have Jupiter, and Jupiter Let's zoom in on it. Jupiter has a series of rings that it has been, oh, maybe it doesn't. I totally forgot to add rings again. Let's add them right now. And rings on Jupiter are meant for one purpose. These rings will create mass needed to maintain its satellites around Jupiter, so that the satellites basically do not fly away. I'm going to give it some more rings, so it's going to have a series of rings, a lot more than what I show you here. But other than that, it's not as beautiful as other planets. It's actually, for some reason, it's white. But these, you have some really beautiful rivers here, some lakes. So it does have Earth-like atmosphere and pressure. Temperature is 16 degrees. Actually, pressure is a little bit higher. It's 11 times the pressure on Earth. But that is not a problem. You will not be able to tell it apart either. But that means you do need to repressurize yourself when you go from Jupiter back on Earth. Then we have Saturn. Let's zoom in on Saturn. Now, Saturn obviously has a lot more atmospheric pressure, but it also has the rings, and it also has beautiful landscape, a little bit more water, and a little bit more gravity, because I actually left it as 2 times the mass of Earth. But definitely more beautiful locales here. I think it's a little bit more beautiful than Jupiter, and it will have less rings than Jupiter because it has less mass, or less mass to begin with, that is. Then we have Uranus. Where are you, Uranus? Uranus is right here. Now, Uranus doesn't actually have as much mass as Jupiter or Saturn, so it will have less rings, but it also has more water. It already started with more water, so this will be more like a water planet. And the thing is, it has a different rotation to other planets as well, so it actually, you can see it spins sort of like, so it sort of spins with its top side toward Sun. So it has a slightly different rotation, but that's not really a problem either. So the surface pressure here is obviously higher, so this would not be like prime real estate, because here you have to repressurize yourself every time you go back to Earth. But since the travel to Earth will probably take a few months, it's not a problem. Everything else is Earth-like. We have temperature of 16 degrees. We have lots and lots of water. So for people that like water, this might be actually a place to live. And the last planet is, of course, Neptune. And Neptune has to have water because Neptune is the god of water. So Neptune, where are you, Neptune? Neptune is totally blue. Actually, this is my favorite so far. Look at how blue it is. It's blue, but its ground is actually blue for some reason. And so is its atmosphere and everything else. So this is like the bluest planet. Has really nice temperature of 16 degrees as well, and a few rings flying around just to maintain that mass. And unfortunately, the pressure here is crazy. It's actually, where is the pressure? It's 679 times the atmospheric pressure on Earth. But once again, not a problem. We could still survive here. We will not be able to tell a difference. It will be a little bit stuffier than usual, but that's okay. But this is actually to maintain the greenhouse effect, because it's so far away from the sun, it needs to have greenhouse effect as the main source of heat. So this is why the pressure is so high. Now, I'm not going to do Pluto, because Pluto since 2006 has not been considered a planet, unfortunately. And it's funny because the probe that has been launched to study Pluto, which actually arrives to Pluto in around December 2014, has been launched before Pluto lost its planet-like status. So by the time it gets to Pluto, Pluto is no longer a planet, it's a dwarf planet now. But in the next video, I'm actually going to try to terraform Pluto as well. But for now, this is good. We have 8 terrestrial planets, lots of space for people to live on. And some of these planets are awesome. I think Neptune is my favorite. Even though the pressure is high, it's totally blue, and I love blue. Anyway, thank you for watching. Please subscribe, check out some of the other videos I posted. And this is Universe Sandbox 2, the best universe simulator ever. Thank you, and good luck to you. Bye-bye.